So, in this video, we're going to talk about the question: a movie theater has a policy that no more than 30 people can occupy the VIP section of the theater at one time. The VIP section has a maximum total ticket price limit of $3,000. It is assumed that the price of a ticket purchased by the customers in this section follows a normal distribution with a mean of $110 and standard deviation of $16. What is the probability that the total cost of 30 randomly selected tickets exceeds the $3,000 limit? Well, this question falls under sampling distribution of sample mean because we are analyzing the probability of the total cost of a sample of 30 people exceeding a given limit based on the properties of the population. The population is all people who go to the theater and spend money, which has a mean cost of $110 and standard deviation of $16. Instead of focusing on the population directly, we analyze the behavior of the sample mean of our repeated sampling. That's why it falls under the sampling distribution of sample mean. So sampling distribution of sample mean, it has the mean same as population mean, and the standard deviation is sigma over square root of n, where sigma is the population standard deviation, and n is the number of people we have in the sample, so sample size. Now, in order to find the probability, we need to convert this information, the mean and standard deviation, into standardized mean and standard deviation. So we follow the Z formula. We can apply the Z formula to find this probability. So what you're going to do is we need to know what is X bar. To find the X bar, we know X bar is total of our number of items. In this case, it's total cost per number of customers we have. Total cost is $3,000 and total limit is 30 people. So when you divide $3,000 by 30 people, we have 300 over 3, which is 100. So the mean cost is $110. Now, in this question, they already gave us the population mean, which is 100. So it's $100, my bad. And they gave us, we have the population mean of $110 with standard deviation of $16. So population mean is $110 and population standard deviation is $16. Now our goal is to find what's the probability that the total cost exceeds $3,000, which is same as what's the probability that our X bar will be bigger than $110, which is same as what's the probability that Z is bigger than X bar minus mu over sigma over square root of n. We are converting into normal distribution by converting into standardized normal number so that we can find this probability using the Z table. So when the Z table has all the probabilities, which is on the left side of the Z score, and here we are finding what's the probability that a certain Z is bigger than this number. So we need to subtract the less side from 1. So probability of Z smaller than X minus mu over sigma over square root of n. Or what you can do is whatever Z we have, we can go to the opposite sign to get the number. Then you don't have to subtract the less than area from 1. So we have 1 minus probability z is less than, our x bar is 100, and means population mean is 110. Sigma is 16, and we have total of 30 people. So using calculator, you'll find that this amount will be negative 3.42. So you have two choices. Either we subtract the less area, we go to negative 3.42 on the z table and see how much we have, and then we subtract that from 1, or we simply go to z equals positive 3.42, and whatever we have, that's the solution. So in the z table for positive 3.42, so we have 3.4 here, and 2, if you look at, this is this column, the third column. So 3.42 gives us 99969. So we have 0.99969. That's the answer if you go to the positive side. But if you go to the negative side and get exactly what they're asking for, probability of negative 3.42, so negative 3.4 is here, and 2 is here. They intersect at 0.0031. So you do 1 minus 0.00031, and in the calculator, you'll see that you have exactly this, if you subtract 0.00031 from 1, which is 99.97%. So there is a 99.97% probability that the total cost of 30 randomly selected tickets exceeds the $300 limit. If you didn't understand anything, then feel free to write in the comment box. I will answer to you as clearly as possible. Bye-bye. See you next time.